Uh, cool. So I was I kind of started thinking about giving a talk for this meetup, and uh, mostly because I thought if I'm trying to revive it and I'm asking people to stand, come and give a talk, I should probably start and then lead the way. So, and then I was trying to decide on topics, and it was last month, and I was working on some relatively complex React application, and I was trying to get some help from some of our AI friends that are quite popular now, like GPT and Claude Sonnet. And I quickly noticed that they are really quick at writing React components. Like in a blink of an eye, they will probably write you like a whole page with several different components with several different hierarchies and state, and it's very difficult to review the code. And I found that they do the same common mistakes that I have done over the years, and I have seen others do over the years, and which basically led me to think that it might be a good time, even though it's been about a decade, more than a decade of React, might be a good time to kind of go over the fundamentals a bit and kind of help us understand the code when we actually read it, and when we're reviewing some code, whether it's written by someone else or whether it's written by AI. It's probably good to kind of have a look through and understand what that component really did, or what could be the potential bugs in there. And while I was doing that, on 12th of September, around 12th of September, Cloudflare had an outage where released the report on 13th, and they were like, I have the quote here because found it really interesting. Is that so? They said the deep dive and the reason for the outage was that the API calls were managed by React useEffect hook, but we mistakenly included a problematic object in its dependency array. Because of this object, uh, because this object was recreated on every state or prop change, React treated it as always new, causing the use effect to rerun each time. As a result, the API call executed many times during a single dashboard render instead of just once. This behavior coincided with a service update to the tenant service API, compounding instability and ultimately overwhelming the service, which then failed to recover. I found it really interesting because uh, I've done that. I was like, and I was really surprised that it happened at the scale of Cloudflare. I I personally don't use effect hooks nowadays to make API calls and stuff. We have better options available now, but definitely in the beginning. But I kind of thought that really uh, drives my point across, that this is probably a good time to kind of go through the fundamentals. And while I was presenting this, I was preparing the slides, uh, and I showed it to my wife, and she said that you might put people to sleep because it's so technical, but I will try to keep it engaging and also keep it interactive. If you guys have any questions, please feel free to interrupt, and we can keep it free flowing. And uh, so as part of the talk, yep. So as part of the talk, you might have noticed it's in a browser. I was trying to figure out how I can show the React stuff working without having to switch between a browser and my code running, and I still have to do it, but I kind of built a React app, which basically is my talk. And this is the React app, which is my local host. And uh, and I have added some interactive examples here just to get a mental model of how React kind of thinks of components and sees components. So the first topic is the rendering. We don't get overwhelmed by all the slides. I tried to keep everything very concise and on topic. But so rendering basically is probably the most commonly used word you'll hear with React, where someone says it's rendering. And there was this guy, I don't know if you guys have noticed, he developed a tool on top of React DevTools, and he would go into these popular websites, and he would run this tool, and he would tag them on Twitter saying that, hey, your your website is just re-rendering like crazy, and he would have this flashing colors where every component would re-render, and then he would tag those companies, and there were like big companies who he like tagged on Twitter, and they kind of went back and fixed it. But what really is rendering in React world, rendering is React calling your component. So when you write function my component, when it calls that function, your component is called. That's what React is really, what it really means in React world when it says rendering. But when it calls your component, it gets a JSX back, right? And that's where the real smartness of React, which you don't really see. What we really see, or what that guy was showing on other people's websites, and what DevTools shows, is actually the commit phase, which is the last phase of the 3-1. So something triggers your state update, your React component re-renders with the updated state, and that's when it performs calculations like, do I need to update this? Really, has it changed? And then it commits it to the DOM, and that's when really we see something on our browsers. So when we say something is re-rendering, we really say something has re-rendered, and the result of that commit is what we are seeing in our DevTools. And to kind of show that, I have built this kind of a component tree based on an example that I kind of started with in the beginning. So I'll first show the component so that you guys can understand the component tree and how to actually understand about React rendering and develop that kind of mental model. That's fine, it's just a win. So this is the final example. This is what I actually started with in the beginning, but then I was like, this is too much. So I was trying to build this dashboard to kind of explain some of the concepts. And there's this top level component where it says good afternoon, and just some text field, shows the current time. And then below that is a separate component tree, which is the actual dashboard component, where the top level shows the stats, and then below that it's a list of tasks, and on the right it shows which user you're viewing the dashboard as. You can change and the list changes, and then there are some filters, pretty standard dashboard kind of a behavior that you would see generally. And so the main thing to note here is that the timer and the message here is one component, and then there is the dashboard component tree inside which all of the filters, the user switcher, the stats, and the task list lives. So with that, I'll probably go back to rendering and look at it as a tree, because that's what React looks at your components as. It looks it as a UI tree, or you would also hear the term render tree, where it basically is a tree with React components. It's not HTML tags. So when it prepares the render tree, that's when it realizes what to really do with the tree. Do I need to replace it? Do I just leave it as is? And so if you look at this tree, the time greeting component that was at the top, that's there. And I don't know if you can see the render count is increasing. Like it's every time the time updates, because the React needs to show the updated time. And that's where it needs to render and then commit it to the DOM. And this render count is just the render count saying that React is doing something here to display the time. The diff, or the intelligent algorithm that React does, is that if I just type my name here, it stays there, because it knows that DOM node doesn't need to be replaced, because it just knows that it's the time that's updating. It keeps track of it and just updates that. And even though it's rendering all the time, every second it's rendering, we don't see any flickering, or we don't see any difference to our eye. The only thing that is telling us that it's rendering is that I put that number there to show that it's actually rendering. Now, this dashboard has children, which are the task stats, task list, and the sidebar, which has the user switcher and the filter panel. Now, if I update anything here, so this kind of follows the principle of lifting the state up. So all the state of these children are maintained in the parent dashboard component so that it's easier to coordinate between the children. And so if I add a task here, you'll see that all of them kind of changed from all of the children have re-rendered. And this one is a new task that's been added. Render count is 1, and all of them have updated. But I will show you one more thing here. So if I reset the count, right, and I go and click add task, it changes the render count for the children, and the dashboard component changes to 3 instead of 2. Does anyone know why this is happening? It's just React telling us that React making sure that we are not making any silly mistakes, and React renders the component twice in dev mode. So this is the strict mode tag we see on top of like every React app that wraps it. Doesn't run in production, but in dev mode we see this strict mode, which makes React basically go over it one more time. But why does it want to go over it one more time? Because React kind of works on the principle that your rendering logic is a pure operation. Your component is a pure function, and when it renders, it should not see any side effects. So the moment you introduce side effects there, it will render. Every render will be different. Your output of the JSX will change because you have now changed the basic principle that React operates on. So when you see this happening, and when you see that it calls my component twice and it behaves differently both the times, you know that there is a bug in your component. So I'll touch on side effects. I'll come to that later. But the main thing, probably the main key takeaway from this slide is that when React looks at your component in terms of UI tree or render tree, and the only way it would re-render is that it first initially re-renders, where you might have noticed there is a function called create root, which basically is your initial render, which basically tells React just render all the componentry from here on. After that, it's all re-renders. It depends on if the state has changed, if it needs to update the DOM nodes, or it doesn't. It does those calculations and commits to the DOM. So initial render and set state, those are the only two reasons React would re-render. Now you would hear sometimes that you will say, hey, the props, even on that note that Cloudflare had, that they said that it's the state or prop changes. So a prop is basically what you have passed down to your children. Like a parent holds a state, and then you have passed down that state to the child component, and that's where it's referred to as a prop. And the prop has changed, that's true, but it's actually the state change that has triggered that prop change, and so it always starts with a state change that you tell React component, now you need to re-render, and that's when React tries to do its whole rendering logic. And I have one more example, which is probably a similar one, which is that this whole list, the green flashing just tells us that this is the only thing that has happened. Like it's not going to update all the DOM nodes. It knows exactly what has changed, even though the rendering has happened, the re-rendering has happened. It knows that it doesn't flicker, it doesn't show you, it doesn't hide any DOM nodes from you, because it knows which ones to replace through its algorithm, which is I think called React Fiber, if I'm not remembering correctly. That's probably the backend logic that sits behind React. So that's a little bit about rendering.
So you're saying in div mode it'll render it twice and make sure there isn't any changes between that. If there is changes, does it flag a little error to you or something?
It will not let you run it. Like nowadays, it's with a strict mode, you'll probably not be able to run it. It will just say, I'm broken, or like it will throw that red warning with a cross. You can cross it out, but it will throw that big red warning saying that you're doing some stuff, and your component will anyways not behave the way you would intend it to behave.
What examples would there be that you would have a problem where you need two renders to happen? What circumstances does that occur?
For example, if you are setting a state inside, which is not allowed, by the way, so React with every step will probably try to prevent you. But for instance, you are allowed to set a state inside an if condition, and you have made it conditional now, which means that when React renders based on that condition, its state, which is basically its snapshot that it sees, will cover that, has changed every time based on that condition, which means the component no longer is pure. So the reason it re-renders itself is that we know that this component, even if it has re-rendered, it's like idempotent operations where you fire an API request, it should not, if you fire it twice, it should work the same way. So it's not that, it's that sort of a concept what React is trying to implement. Does that, or I can cover some of the snapshot bits, and then maybe we can see if that clears things up. That's probably what I had React rendering. And so I'm going to use state, because use state is the kind of where we start triggering stuff to actually tell React to re-render and commit to the DOM. And when we think of state, it's think of it as a snapshot or in time of like a photograph of the component that React sees. So when it sees a component, it knows that this component has this particular state. The state is maintained by React. The state is not in the component. It's part of the component, but it's not actually something the component controls. It's React. The analogy is that it's a shelf where React keeps your state, and when your React component renders, it pulls the state and says, this is the new state, and then based on that, it creates your event handlers, your props, everything changes based on that new state value that you have received from the shelf. And this is where we probably need to understand how we are trying to set the state. Are we trying to replace the state, or are we trying to queue something so that every state change takes into consideration what the previous state was? To demonstrate that, I have this, try to make this animation. It's buggy, but it will work. So here, basically, there's the event handler for this click event is calling the set state with the +1 value. So it starts with 0, and the counter will be incremented by 1. And we are calling the set state 3 times in here. So when we do that, as we see, every call within that handler just does replace with 1, replace with 1, replace with 1. It never sees what value the shelf really holds, because in that snapshot, when it was trying to run this, all it could see was that 0 was given to me from the shelf. React has told me the state is 0. Now, for any operation, use that as their state. That's their snapshot. And when we run it 3 times, even in the event handler, it doesn't go to number. It goes to increment it 3 times and become 3, because it never sees the new value. It always knows that 0 is the snapshot that I got, and that's what I'll operate on. And React will not make any changes until all the operations in the event handler has been completed, which means that even though I have clicked it, and click it again, triggers it, renders it, commits, and the value still increments by 1, even though we have triggered the set state 3 times. And this was intentional, because here we are telling React, basically, I'm starting with 0. Can you please increment it by 1? And React will say, I know the the last state was 0, I'm just going to replace it with 1. But what if you want to actually increment it by 3, where React is aware, or React waits for the first value for the state to update, then it knows that it has incremented to 1, then it increments it again, then it changes it to 2. And that's where updater functions come into play. Have people used updater functions much? And, yeah, it's one of those which you really don't think about, but only when you encounter bugs, like weird bugs, that's when you will probably see, oh wait, there is an updater function. I often forget that there is an updater function. The updater function basically says, so if I'm saying set state, my current value 0 plus 1, it says replace this value with 1. But when you pass an updater function in that in your set state, it basically tells, so updater function is basically that inside your set state, your current state plus 1. What it does is that it puts that function in the shelf. Basically, when it re-renders, it knows that I need to execute that function instead of just blindly replacing what was already there, which means that we can now queue stuff, which means that if I click it again, you change it to 8. However, you'll see that the render count it's still one render, but when it renders, because it's a snapshot of the state, it knows that I have received this updater function as the next thing to run, and that's when it will make sure that it takes the value from the shelf, updates it, and takes the value from the shelf, updates it, and then it commits it, which is when we actually see the value getting updated on the screen. And it doesn't matter if we do it. I'll probably if you do it async as well, it doesn't matter how you do it. Even if you're doing async, you have to ensure. In this case, the only difference is that the render count increases because we are letting the thread we release the thread because we are telling it that we will get to this action later, and it's basically the same thing but after a delay, and it's still using the updater function logic, and probably the key takeaway for this from this slide would probably be to just think when you're using set state, do you really want the state to be replaced by this new value, or do you want the state to be queued based on the previous value of the state?
When does the render occur when you pass in an asynchronous function? I've never done it before. Does it await the async function? Or
So if you think of the shelf analogy, when it sees this has come, it has puts it in the shelf, and when the moment it is released, moment it is allowed to do something afterwards, that's when it tries to grab that new value from the shelf, whether it's an updater function or just a replace value. And the moment it grabs that, it knows that it needs to re-render the snapshot because the snapshot has now changed. That's the old snapshot. The new snapshot is basically the value that you have told it to update using either updater function or the value. And that's when it knows that it needs to re-render. So every time, if you don't use async, if you're just doing it in a synchronous way, it just keeps adding to your shelf and this exits and then gets to the shelf afterwards. And now it is like, oh, wait, do I need to replace it? Do I need to update it? Do I need to queue it? And every time, when you do an async operation, that's when it gets the opportunity to actually go and look in the shelf and see do I need to update my snapshot?
But does it await it? Does it await that asynchronous?
Yeah, so the function will still be executed. It will not forget about that function because that snapshot already has that function and we have scheduled it to kind of run later, right? So it will, yeah. So there are examples. There are some really good examples in the React dev site nowadays where they basically a similar version of this, but they have an alert. So you click that, and then you wait for the alert to appear, and the alert is still looking at the snapshot from the time that the alert was triggered in. So it's not aware that the React has re-rendered or React has got a new value. It already sees that. So as long as we look at our component, look at our state, and we realize that it's a snapshot of that current state. That my JSX, my props, my event handlers, everything is a snapshot based on that particular state. And when we're setting state, we just be mindful of we are going to queue it or we just want to replace it. I think we should be good. React will probably take care of, like most of the bugs, React will probably just take care of you and they'll say it just works. And
Maybe following on that, if you set two different states in one, and one is synchronous and one is asynchronous, would there be an intermediate render to process the synchronous update before asynchronous results?
Yeah, because it will get the time to actually go and look at the asynchronous render, because it's still, all it is trying to do is it is trying to complete your make sure that whatever next state it is you're trying to get it to, it needs to do it through render, right? So that's where the rendering is just an effect of you setting the state. So moment you set the state, you've kind of already told React like, hey, I want you to re-render really, and that's where that's the trigger basically. When we think of set state, we just know that this will re-render and React will take care of it. And most of the time, React will just be like, yep, you have told me to set the state. I will do the calculations. I'll do the stuff that needs to be done. I'll look at the shelf, and I will come back to you and then render it. And so it's and related to that, there is another thing. I was touching on the render tree before and the UI tree. And you probably worked with lists and you have got the error that the key warning that the key is missing. And then you would have seen those blog posts where like you don't use index as your key because that's the easiest thing that to do. And we just go over it and we just go like map through it, get the index and set the key as the index and forget about it. Again, most of the time it works. So why would you bother getting an ID from the server and setting it? And that's what I wanted to touch on, because key in React is a special prop that gives React some additional information about your component tree, which basically tells it that, hey, this component, even if it renders somewhere else, it has an ID. This is the ID that you need to make sure that your state matches with. And because it looks at the tree and it sees that this component has moved from like this from third position to fourth position, you have sorted it or whatever, right? And now React is no longer able to track the state without a key, right? Because now you have a list and you have reset the list. Your whatever was at 0 index is now a completely different component that is rendering, and React will find it really difficult to match the state. And that's where key gives it extra hints. Key tells it that, hey, this component has moved, but this is its ID. So go look at the shelf. And the shelf analogy also holds up here, because when you have multiple use states, it's basically arrays. So it doesn't have any identifiers. When you do use state 1, use state 2 in the same component, doesn't have any identifiers with that use state. So all it is really relying on is that what position is this being called on, and that's why hooks need to be at the top level of the component. So all of this kind of ties up to how React kind of views your component. It views your component as a snapshot, but as part of the UI tree. And then when your position in the UI tree, position of your component in the UI tree changes, React needs to know where to look for that state. And that's what key does in a list. And list is probably the most common use case, but you'll probably find, and I'll give you an example as well, where you will probably find cases where you'll need to provide a key, even though you thought React is behaving, or React should have behaved you need to provide a key for it to behave the right way. So just as a demonstration of the list thing, so I will click the Learn React. Hopefully it's visible. Learn React, the click count has increased to 3. And I will just go ahead and delete it. Well, the build project is now click 3 because React has no idea, because 0, what was index 0, the key was the index, and what was index 0 is now become a different component, but it's like, it doesn't see it, right? It sees it like your position 0 has become your key 0 is this component, and my state was 3 at that point. So it pulls it, and you see that those bugs coming up. Same example, if you just pass a stable ID, which just like task ID in this example, updated it to 3, delete it, it's gone with that component. And if I reset it, it still doesn't come back, because but the moment the component is gone and the key is no longer there, it knows that it needs to destroy the state and destroy the component along with the component as well. So this is probably the most common use case that people you'll find will warn you about, that when you use the index, it'll probably work fine. But when you use sorting and pagination and you're trying to change the list, I think the warning, I guess, what most people give is that if the list is not changing, it's fine to use your index, because if it's not changing, it doesn't need to keep track of your state, doesn't need to keep your state mapped to a position in the list. So it doesn't really matter if you use an index. In that case, it's fine. But yeah, if you're doing any kind of sorting, or you're like dynamically updating list items, you should use an ID. And
In essence, should you always keep these things unique just to cover yourself? It sounds like you probably should, from what you're saying there. If you're using that, you're going to potentially run foul and cause someone else a bug later when they're trying to answer code.
For lists, yes. For lists, that's definitely the case. I would definitely recommend having a key. But for components, you will usually, when you start thinking of your component as a render tree, you will probably start placing your components in a way that makes sense for the UI. So your position itself will make sure that React behaves the way it is. It doesn't need a key. The key is just an extra information that it needs when the positions can change, but React needs to know that this component has actually changed position in the UI tree, but I know that it is mapped to this ID, so I can keep the state alive. So the component...
It's tying a particular DOM element that's already rendered, and so you can kind of set that, because it's
So there's no harm in putting it in there.
There's no harm. You'll probably be someone looking at their code. They'll probably be slightly confused, why is there a key there? But apart from that,
It almost feels to me like it's best practice to have it there.
it would have been if your components if React was not so good at maintaining your UI tree and maintaining the state of those trees. So I'll show you an interesting example that kind of that's what I was trying to show. That's good. So here we have probably a fairly common use case where you have two tabs, two forms here, just the same component on left and right. So we'll probably look at the left one first. So here, if you look at the code, what is written, I hope it's visible. If you look at the code here, I'll remove the highlight, where it says editor type is, if it's user, call the profile editor component with type user, and if it is not, just call the profile editor component with company. Now we have probably written code like this all the time, not thinking about it. But from React's perspective, when it sees as a render UI tree, what it sees is that, okay, fine, I'm looking at this component. Oh wait, there is a condition here where it says if this is true, render this component at this position, otherwise render this other component at this position. The position from the render tree perspective is the same for both the components, which means that to lead to things like, so I'll just do Subhra, do that. Now when I switch the component, it still maintains the state, because from React's perspective, because we are looking at it as a UI tree, these are the same component in the same position. But if you want to, there may be use case that you actually want this, most of your applications nowadays, especially the single-page apps, if you type something in the form and you do something else somewhere in the page, it still retains the state. And even though you want that state to be there because you don't want the users to be writing it again, but there may be cases because of the form fields have like some different requirements that you want to display. What do you do in that case? There's one way is to put a key there. If you put a key there, even this component will work because now it has like a different key for each component. It knows that even if it's in the same position, I know that this ID, the key is mapped to a different component. Another way to do it is to do something like this. Now this probably conceptually looks the same, but the thing is that, and probably in your code review, you'll probably say, don't do this, probably use a ternary operator and do that. Because we generally don't think of it as a rendering UI tree kind of a thing. But in this case, when React looks at it, React says, oh, when the type is when the editor type is user, I need to call this profile editor component. It'll go to the next line. It says editor type is company. I'll just leave it as empty. But React still considers this as a position in the render UI tree. It's an empty position, but it's still a position for React, which means that which means that these two components are at two different positions for React. And that leads to behavior like this, where you go, hi, that resets because the component is no longer there. It says, well, your position has changed. So basically, this is, if you look at it as a tree, it goes root component, diverges, profile editor company, profile editor user. This can be empty, doesn't matter because there is a condition there. But before that, on the left side, we basically said, this is a root, this is a component, profile editor. It can be a company or a user. So all it cares about is the position. But if you want to override that, you want to tell React, I want to help you, that I know what I'm doing, and I really want to do it this way. Just put a key there. That's what tells React that, hey, actually, it might be in the same position, but it has changed. The identities are mapped to a key. So I kind of wanted to touch on this because this is kind of probably the most common issue, and you probably not encounter any bugs also in this case, but you will, because it's a minor thing unless there is some like sensitive information getting passed on. So you'll be like, yeah, that's fine. It's too difficult to change. But it's when we start thinking about it as a render UI tree, we kind of start making sense of how React looks at it. And there's some notes here too. I'll probably make this app is in my private GitHub repository. I'll probably make this public soon. I have to do a bunch of commented out code like you would expect in production code. So and a bunch of things that I was trying, and there are bugs as well. But I'll probably open it to public and put a link in the JS meetup group so that you can also contribute, and we can. I don't want to create a duplicate of react.dev. It's still there, and there are multiple visualization websites as well. But I thought this was kind of making sense to me, and how I visually learn and how I want to show the concepts that React, the core concepts of React. So yeah, that's mostly.
I'm actually surprised that even though it has different props, it's actually rendering it's the same component that you said in the reaction.
Yeah. Because it says it really looks at their component in the position with respect to the position if there is no key. So it always has to be, and this surprised me as well when I was like, wait a second, that's how, because it's a render UI tree and it says there is a position. And this one is also not very intuitive because you would think that this empty doesn't really matter, but this empty position also matters for React's UI tree because it kind of branches and sees that this one is, something is there, I will just meet the condition and render it.
Can I ask a potentially dumb question, which, because I don't know a lot about React, I'm coming at it from pretty much knowing nothing.
No, that's all.
If you zoom in on the left-hand side there, on that code, the first curly brace to the last curly brace, is that indicating that it's a view element?
No,
Is that is what's causing it to render differently?
No, the curly braces is just for me to add the ternary operator. Yeah, so just to add that ternary logic in here, and same for here. Yeah, the curly braces are just part of JSX kind of writing logic, sort of JavaScript logic in there. But yeah, it's either the position or your key that needs to be considered when we're looking at the UI tree, and I think somewhere here I wanted to quickly touch on useRef. Have people used useRef much? It's been around for a while, but I kind of reach out to useRef. It's also labeled as escape hatch by React, but it kind of is a hybrid of a variable and a state, where you can React knows that it doesn't need to re-render when you set a useRef value, but it's not like a regular variable where it gets reset with every render. So if you have a situation where you don't want React to really react, I guess, or to render, then you can use useRef. I have definitely encountered issues in projects where useRef kind of was like light bulb moment, like, oh hey, wait, I don't want this to re-render. I just need to store it, and I just need to keep track of it myself. I don't want React to kind of take over and do its rendering and stuff. But the local variable will just be like, every time it says, it's a snapshot, right? So every time it says, it's like, oh wait, I've initialized it to 0, it has become 0 again. And I might have removed that from here, but yeah, it's a work in progress. But I just wanted to touch on useRef as well, because it's kind of, when you first look at it, might look like, oh wait, useRef also seems like something that I can put my values in and React will not clear it out on every render. But yeah, it's then.
Which it's basically React won't react to changes in that.
Sorry?
React only reacts to state, not to refs.
Yes. Yeah. And
run into that with like mouse movements.
Yes. Yeah.
React state won't update as fast as the
Yes.
moves the mouse.
Yeah. And we also need useRefs a lot with map work, when you need to render a map and you need to store in like a reference to that map and do some stuff with it, add handlers and stuff like that. You don't want to re-render every time you're doing stuff with that map instance. So that leads us to useEffect. That's probably the most bugs that we'll find in any React application will be around useEffect, in my experience at least. And the kind of bugs that Cloudflare also encountered is probably just not understanding useEffect or how useEffect, or when really it runs. So when we understood rendering, we now know what triggers the render, and then the DOM and the DOM diff and DOM commit when we actually see the output. But useEffect is I can see why the React team had to come up with something like this, because you want your components to be interactive. That's the whole point of it, to change. But then if you want to introduce a side effect, it's no longer a pure component. So the side effect should live in an event handler. That's the most React way of doing it. Your event handler can have all the side effects that you need, and it's fine, because the event handler is not part of the rendering logic. So when we think of it as a pure component, we have to think of it as, when this function is called and when React looks through the component, it shouldn't see anything that will change depending on some other factor. So when it renders the component, now the event handler is something that when you click, when you hover, that gets triggered. That's out. The rendering has already happened. So your pure operation is already done. But if you have a situation where you you want to do something because of the rendering, which is the example from the React dev documents is the chat room is probably the most probably the best example. I was trying to think of other examples, but I was like, yeah, that chat room thing makes sense because when you render, you actually want your chat room connection to be there, or you'll have to be like, do you want to connect? Yes, click that button and then it connects. So the best experience will be you open your chat window, it connects automatically. So, and that there is no event that happens because of it. It's the rendering itself that tells it that, hey, actually, I need to run this after the rendering has happened. And that's where useEffect comes into the play, and it's also marked as an escape hatch in the React documents because it can lead to various bugs if not written correctly with the right dependencies and stuff like the Cloudflare thing. So to demonstrate that, I will show when React actually runs the effect code. So this is the chat room thing that I tried to replicate. It's in a general room where it connects to the general room, disconnects from the general room. Again, this is dev mode, so we'll see that connection and disconnection happen because the disconnection, oh wait, I didn't touch on the cleanup function. So the useEffect has a function that it runs, which is the actual side effect that it needs to run. Then it can also return an optional cleanup function, which is run every time before running the effect. So basically, it will read through render your component, it says there's an useEffect, it will come back to it, and then it will see is there a cleanup function that I need to run, has been returned by the useEffect, runs the cleanup function, and then runs your useEffect. So every time, so the main problem with doing fetch calls, I guess, with useEffect is that you need to make sure your cleanup function does the right thing, and that's where libraries like React Query really makes it easy for us to not worry about all of those things, and even if you're making connections, have you disconnected or not? So those sorts of things are really things that we need to think about while writing useEffect whenever we need to. So now this is connected to general. Now if I click travel, the component has rendered with travel. So when I have clicked travel, it knows that travel, it has already rendered, but now it goes back to the useEffect, cleans up the general connection because I have returned a cleanup function, and then it comes back and then connects to the travel component. And this is probably the key thing that we need to understand when we are reading a code that we are reviewing and seeing that, hey, there is a useEffect there, but is there a cleanup function? Do we need a cleanup function? And if the useEffect runs, will it go into an infinite loop? Because a useEffect will run after each render. So if you're setting something in the useEffect that causes a re-render, basically you are stuck in an infinite loop where you go useEffect, render this thing, useEffect, set the state, re-render. That re-render causes useEffect to run again, setting the state, just an infinite loop. And that's where we'll get those maximum dependency depth reached kind of errors, and your browsers and your laptop fan will start to blow up. And same with music, it knows that it was travel before, disconnect from travel and disconnecting to music. So this is just to demonstrate that this is the cleanup function will always be called before executing your useEffect. And I think I had a dependencies section as well. This is another tricky bit with useEffect. So as I said, useEffect runs on every render, right? But you don't want it to run on every render. You want it to run when something changes or some value has changed. And that's where the dependency array comes in, where you say, if this thing changes, run this useEffect, otherwise just ignore it. And in this example, I've added the count. So the count and text both are a state in the same component, but I've told useEffect to only run when I increase or decrease the count, when the count state changes. It doesn't care what the text does. So basically, if I increment the count, the effect has run. But if I type in text, the effect doesn't care because that effect has a dependency that says that count is the only thing that you need to look for, and that's when you need to run. Now there is a thing, so the main thing that probably we'll need to learn here is that there are things called stable identity and there are things called reactive. A rule of thumb is if you have anything in your component function logic, that's probably reactive because every render it will see it, it will try to run it, and that's going to cause some changes. But there are exceptions to it which have stable identities, like the set function that useState returns, that is guaranteed to be stable. So if you pass it to a prop, you don't need to be worried that the function will create a new function. It's always stable. Similarly, useRef, the ref object returned by useRef is stable, so you don't need to add it as a dependency to useEffect. So when you're writing a useEffect, you will probably be warned about that ESLint plugin. How many of you have used that and ignored that ESLint plugin? That's probably, I have code bases where all I can see is ESLint disable next line. Because we don't understand why it's complaining, and when you add that value, actually it starts creating bugs. You will be like, it's working fine. I added a dependency that ESLint asked me to, and then it started causing bugs. And when that thing happens, the right thing to do is start thinking about the React rendering and seeing how we can move those things out of useEffect, make them non-reactive. Basically, tell useEffect that these are stable components. And sometimes it's not possible. You have to just ignore it. I have found cases where you just have to ignore that. But then, and I think React team also knows that, but they don't document it. And then quietly they release something like useEffect event. Have you seen the useEffect event in the React 19.2 documents? This is basically what the situation that we're talking about, where you need something, it's a reactive value, but you need some way of telling React, please don't consider it as a reactive value. So they introduce yet another hook, which is not confusing at all, which is called useEffect event. Which basically, this is an example directly from the website, because with Vite, I couldn't get to React 19.2 while I was doing it. So I couldn't really play around with it. But what it really does is that we want the log visit to be called only when the URL changes. The URL is passed as a prop. But number of items here, because it's part of your component and it's evaluated during your rendering, this is a reactive value. Now, you don't want the number of items to be included in the dependency array. What we would do currently is that we'll just do ESLint disable next line for this particular rule. But what React has done with this useEffect event is that you create another hook, useEffect event, and now this basically tells is the number of items is a stable value. It's no longer reactive, and then useEffect is fine to use that function returned by useEffect event to call without worrying about number of items. So this is, I haven't played around with it in any live code, so I am not really sure how it would work out in practical applications, but I can definitely see from past experience that this has been a problem, and we would just disable it. Yes, please.
So this is roughly just saving a ref based on the first time that function was created.
Yeah, I don't actually know what useEffect event really how it does it, but yeah, it's just does it. I don't. Yeah, I have no idea how it. But yeah, I found it really funny that the problem that they tried to solve a problem with useEffect, and that created problems, and then they solved it by creating another hook, which is very similar to useEffect, and it's called useEffect event. And now you have to keep track of all these hooks that. So basically, if you're trying to run a useEffect, you should be then keep in mind that, there is a useEffect event that I probably should consider if I need to make this reactive. But I guess the React teams. What the React team was trying to push is that don't use useEffect at all. I think it was Remix or React Remix, I think, when the Remix version which I don't even know which version they are in, or they are even exist or not. But they claim that we didn't use a single use effect in the entire.
I don't use it on React Router version 7, which is the next version of it.
Right, yeah. So it kind of becomes like your something to boast about. Like, I didn't use effect, but from practical experience, if you're writing applications, you're not writing frameworks, so you'll probably encounter things that you'll need to put in your use effect. But yeah, understanding when use effect runs and that the cleanup function exists. This is also something like the updater function, really, because you write the use effect, you write the dependency array, the ESLint plugin is happy, you're good, but you don't think that you might need to return a cleanup function. So that's something to remember. This is the ESLint plugin React hooks. I remember it by heart because I have written so many lines to ignore this in this hook. So I know this by heart. So that's that. I think that's more about dependencies. And what happened to Cloudflare is basically they didn't manage when the reactive value in their case was an object, and when, for example, in this case, if it was an object and they didn't do the use effect event, every time the object is created, even if it is passed as a prop, if it's a new object, it'll run the use effect every time, and then that's what broke it. But I probably have an example for that as well. Not to use, just quickly glance over those. We probably already know most of it. If you're a lot of pattern, this is something that I've noticed when React hooks were first introduced. I think a lot of us did that. At least I did. I did this. I'm like, if I need to filter it, I need to do it inside a use effect, because otherwise, how will I tell it to use the filter state? But this is such a roundabout way of doing things, because when React renders, it will go through it, it will run it anyway, and you don't need to tell useEffect to do an extra round of it. But then the problem is that you don't see the bug, right? Because React is so efficient in calculating it re-renders, and like it re-renders, it commits it, you see the updated state, you're happy. So you don't really see the bug, but it's just makes React work extra hard to kind of figure things out, and also makes it less readable, I think. Just doesn't follow the logic, follow the rendering flow of what we just learned. And use effect. So most of these examples, so I was trying to see if I can really show the difference, but it's not possible because it just feels like everything is working fine. And so I'll just skip this because even if you use the use effect version, it just works really fine. It's just React handles it. React is forgiving that way. So I'll just skip this example. User events should be in the everything. If anything can be in an event handler, just put it in an event handler. Don't bother about use effect at all. And same with this example, and I've just put something here. But the golden rule, I guess, is that if you can calculate something during render, you don't need an effect. If something happens in response to user action, it belongs in an event handler. Effects are synchronizing with systems outside React. So it's basically something that it doesn't fall in these two categories. You can't calculate it during render, and you can't it doesn't wait for any user interaction to happen for that calculation to happen.
You mean systems outside React?
It's just browser API, whatever. Like it's the React, the browser, you're calling the browser's API to do something, play a video or something. Even that is like an external system. So React is basically not aware of it. And that's when this was the definition that they, I think, released it when they released use effect, and we thought like, oh wait, if I need to make an API call, just need to use effect, and then I make a fetch call inside the use effect, and there are a bunch of use effects with the same fetch calls. Then you would put custom hooks on top of that, and then it just becomes too difficult, and then you have to pass the dependencies, and it's been use effect has been super painful because of the way we used it. I've put some links here about some of the React dev documents, but it's mostly going over the same concepts, but in the official docs. So lastly, use callback and use memo. Well, this I was debating if I should put this slide or not, but I thought if I'm talking about useEffect and dependencies and how the Cloudflare thing happens, we'll probably need to touch a bit on use callback and use memo. These are basically optimization methods, but it's not. It's the recommendation is don't reach out to these unless you really need to, because React itself is really fast at figuring things out, and it has a smart algorithm under the hood that it will mostly take care of things. But this is the example that I was talking about, where if you have a config object, imagine this is the component and this is the config object you have declared in the component. So every time it re-renders, it gets a new config object with the ID, config ID, and config name, and the effect, use effect that is dependent on this config will run always. But you really want this object in there. You can't really do away with it. So that's where you can put useMemo in there, which basically tells it that if this dependency hasn't changed, just don't recreate it. Just return the same memoized object. And so if I show the demo, change config ID, this changes, this doesn't. Config name again changes, and this remains here. So it's kind of what useMemo, the most common use case of useMemo is to basically, if there is an operation that is causing my useEffect to run because of my object references changing, then it's probably and I said it's the most common use case because it's ideally you can use it for optimizations as well, where you have like a complex calculation that you need to do, like going through a list of items and doing some complex logic, and you can wrap that in useMemo so it don't have to run it every time unless the dependencies change. But I think we are better off not doing that as the first thing, unless it really becomes a problem, like a really like we can prove that this is the bottleneck. In my experience, it hasn't been a bottleneck so far. So I kind of, because it's still an operation, right? And useMemo is called during rendering. So it's during the rendering, you're basically telling React, even if it doesn't need to run it, it will still need to do the calculation to say, oh, has this dependency changed? Do I need to run it? So it's still a computation that needs to happen. So it's not free. So it needs to be used carefully. So that's, and I have like also, useMemo has caused so many bugs for me as well, which were very, very difficult to track. Use callback. Sorry.
I remember working on a project that we had problems with re-render. We couldn't find where the re-render was happening, so we ended up just chucking useMemo everywhere.
Yeah. And I know, and there are lots of devs who, by default, if they're writing something, they will wrap it in useMemo or use callback, which is I think fine. It's just you're just being safe. It's going back to the key thing. Like you can add the key always, or you can use the useMemo always. It's not going to be problem, but you're introducing extra things that React needs to worry about. React needs to compute instead of its rendering logic that it is built to do.
And it might be more important if you're building like a context provider that is used by a lot of other components.
Definitely. What I try to convince myself is that is it if I put this, does it really, like I need some data to kind of really convince myself that this is, and you can use console.like time ends and stuff like the timers to really see, is this really giving me like a huge performance gain or things like that. But yeah, it's definitely useful in cases where really really want, like, please don't change unless I tell you to change. Same thing with use callback. Now I use callback, I find it more useful, or at least I tend to go for it more, because if I have a function, that I'm passing from a parent component to the child component, and that is not a set state, which means that it's not guaranteed that it's a stable function. In that case, I can use useCallback to make sure to be a good citizen to the child, basically saying that, hey, it's safe to use that as a dependency because I have made sure that I have wrapped it in useCallback, making sure that the function doesn't change unless it needs to. And if the function changed, then it's valid for the child component to react to that function change. But if it doesn't, so it's just being a more, unless like I try to avoid passing functions, but if I need to, and if I know that this is probably going to be used by the child component in ways that I cannot predict, it's probably better to just wrap it in useCallback. And yeah, that's mostly it with these two. I think the last thing.
And
Sorry.
with that config that you had as your first example, you're changing the config ID and name, but if these were just constants, it would be even better to just move that
outside the component. Yeah, correct. Yeah, so that's why React kind of delayed having, I guess, they were like, it was not prioritized. They used effect event hook because they're like, you can always restructure it in ways that makes it look non-reactive, I guess. But yeah, that's a very valid point. The final example is this. We've come back to this. It's almost there. I have found a really weird thing that I wanted to show everyone here, is that if you guys use React Dev Tools, it's useful, but it's also buggy, which I realized. So when I was trying to look through this example, and I went to the profiler, and I went here, and there's a setting here which I've turned off because it would have been super annoying. But when you're developing and when you're trying to understand the React, when it is rendering and what things in the page are rendering, and this is also a similar tool that this guy used to kind of tag those big companies that your websites are shit. So highlight updates when components render. A warning: don't keep it turned on. So so now I've done that. You can see this was confusing to me because I was like, you can see from here, I don't know if it's clear, that the timer component is rightfully re-rendering, but what's up with the cross icon and the links there? And I was trying to figure out why are these things re-rendering, and I found that people have also asked this question and they have raised this in the GitHub issues, and some of them the discussions have been closed. But it looks like one person was saying that if it is a div or like a native HTML component, React DevTools sometimes highlights it because of some bug in the code in Fiber, like the underlying engine of the React framework. It highlights them as rendered, which re-rendered, which I didn't know. I only learned about it when I was trying to, I was looking at it and I was trying to see why is this rendering. And even if you close it, the menu thing will keep highlighting because it's, and I tried to prove it. So now I'm going to like a very risky territory. So I'm not guaranteeing anything will work or not work. So so I created this task link component. So I thought maybe I'll just I tell it it's a React component, not a native one. So I did that. That's the test link. And it's still happening, but, oh wait, I'll try to, this final example, did I name it as, oh, this is the test one, right? So if I do something here, it still renders. Like I found like the logic in that is probably not the accurate one. That even if I told it it's a component by wrapping the li in that component, but it probably still sees that it's an li, but it's, yeah, I didn't understand this, and I wanted to show you that this is something that that is, and if anyone has any explanation for this, I'm happy to discuss. But yeah, that's something. But I wanted to, apart from that, what I wanted to discuss a little bit is just a review, I guess, is I'll probably turn this off because this is going to drive everyone crazy. So turn it off. So the list thing, right? I wanted to show it here as a live example as well, where I have this implement user authentication and set up CI/CD task here. Implement user authentication, I'm going to say 10 hours, set up CI/CD 20 hours, right? Now, what I'll do is I'll try to show the component on this side. It will be easier. Maybe that side will be. Maybe this side is fine. So I'll just grab this one here. So here you can see the key is 1 and 4. This is the task ID of this task, which means which is telling React that even if the position changes, I want you to make sure that the keys, the state, the shelf that you're looking in has this ID. So if I sort it by high to low, low to high probably, yep. CI/CD has become the first component and the implement user authentication is the second component. But because it's associated with stable keys, the React makes sure that the state is not destroyed. And more so, even if you're, why is it, okay. Now, if I change it to this user, even when I look at this, the CI/CD pipeline. So this one is a local state. This state has not been saved. So this is a local state to the component, but React still keeps track of this state even though I have completely changed the list, because it knows that there is a stable ID and 1 and 4 are still associated with that component. So it still keeps 20 and 10 here with the CI/CD and the implement user authentication. However, if I go to this user doesn't even have these two components. So 1 and 4 are no longer here, right? So what happens if I go back to this user? The state is no longer there because React has destroyed that state with the component. It no longer sees that ID and it's no longer in the position and no longer has the same key. So it destroys it, and it's sometimes you want one behavior is not better than the other. It just depends on the use case. So whatever works for the use case. But I just wanted to show that this is a tricky thing when we have local state and also we want to make sure that the state either is retained by React or not retained by React. And to do this, to actually demonstrate this, I did an anti-pattern which I wanted to show quickly that this is something that we should not be doing, is that we, oh, sorry, yep, is that, yep. So what I'm doing here is that to keep, so the ideal situation would be the parent component maintains the state because there are multiple children that rely on that state. But to demonstrate that, I created state here, which is the local state, and it tries to synchronize with the parent state, which is the task here, which is actually what happens when you click update. So the local state changes when you type something, but when you click update, that's when the parent state changes. And then we are in a situation where now I need to keep track of when the parent state changes. I need to synchronize the states again. So basically, I have this useEffect where I'm looking at all the parent properties and then setting the state. So this works fine, but this is just roundabout. We have extra variables, extra code that we have written just duplicating the logic that the parent state could have just handled. So I just wanted to show that this is something that we will probably try to avoid. And I think this was a really long talk. Sorry about that. But yeah, I think that's about it. There are references here that you can use some of the gotchas. These are the DevTools gotchas that I found. some of the case study of the Cloudflare and hooks. How there are some good visual guides as well here that already exist that show you how useEffect works and how you can just interact with it and then understand from it. And there is also this good article where this person has really explained how arrays are used for hooks and how without IDs React can make sure that useEffect the hooks keep track of their own state. And no, that's probably me. And thank you so much. I think I'm happy to answer any questions. Yeah, it's a long one. Sorry, I think there's too much information, I guess.
That last example you show where you lose the state because we're taking off the tree.
Yeah.
Is that a good reason that you need to use some sort of statement if you're using external library that should we just skip using use state?
We will need use state, yeah, some form of use state. These libraries will also need to do use state somewhere to kind of make sure that it triggers the re-render. But state management libraries are a topic, I guess what I feel, I usually try to avoid them because of my initial experience with it. I used Redux in one of my first React projects, and I'm paying the price for it still after 6-7 years. So I think it has made the code really coupled with also it's also me not using it correctly, but it's also like Redux making I look at the code now and I'm like, shouldn't really have used Redux. But I usually try to go use state. Okay, I need more complex state management. Then I try to use context with reducer pattern, and which gives me the flexibility to kind of see, will it really grow or is it growing or expanding? And if it keeps growing and expanding, which means that it's additional code that I need to maintain, and that's when I try to reach for like an external state management library. Kind of keep an eye on how complex it is getting, and yeah, that's probably my thoughts on state management libraries. I usually try to avoid them unless there are some good ones. I think now where we have distributed like a distributed store instead of like a Redux store. And I forgot to touch on one of the really good libraries that I've used recently is Immer. Have you guys used Immer? It's really make sure that you don't have to. So every time you set a state, you need to create a new object. You need to do like destructuring and like finding the key, setting it. But Immer is this tool where you just get a draft object, which is based on the proxy, JavaScript proxy object. It's nothing new, but it kind of wraps it in a nice manner where you just don't need to worry about sending. I need to create a new object to actually tell React that this has changed. So, but yeah.
That's what RTK toolkit is using as a wrapper around.
Oh, really? Oh, okay. Cool. Yeah, I haven't seen the toolkit yet. I was like, yeah, it's really cool. I really loved how I don't need to go and destructure the object and like find that thing and do a spread operator and things like that. I quite liked it. Yeah, if you have any more questions, otherwise, yeah, mingle. No worries. Thank you so much.